All right, here's our topic, and here's our objective. And what this objective means is if I know the shape of a molecule or I know the picture of a molecule, what does that mean? Does that tend to be a polar molecule or a nonpolar molecule? This is being water or bent. It can be or tends to be a polar shape. A classic example, like water, of a nonpolar shape is carbon dioxide, and this shape is linear. The dipoles cancel out. So even though it has polar bonds, it's a non-polar molecule. There are certain shapes that will tend to create this, and there are certain shapes that will tend to not create this. And the video is about delineating which ones do it and which ones don't. The reason it does or it doesn't has to do with the symmetric nature or the non-symmetric nature of the molecule. Where symmetrics, that tends to be nonpolar, but those that are asymmetric tend to be. And I notice that these are a little bit off, and that kind of annoys me. Now I'm going to go to PhET, and I'm going to go through the shapes. I'm going to say them and show you and talk about each one. At the end, and they're right here down at the bottom, you can copy them, or at the end I'll go over it all with you. So a linear molecular shape is, this linear shape is a symmetric shape. You can see it's even on both sides of the central molecule. You can cut it a million ways. The next shape that tends to be very symmetric and nonpolar in nature is a trigonal planar. All right, that's a very highly symmetric shape. The next one is tetrahedral, and you can see that this molecule is very symmetric. It's even on all sides. Because the way it doesn't look at first, but when you rotate it, you can see you can superimpose everything on every side. The next one is trigonal bipyramidal. This one's kind of cool. You can see this is the same. I can like kind of cancel out. And it's also cool when you look at it like that. You can see that the one behind is highly symmetric. Or I want to, and then another thing, this one's pulling up some distance. These two are pulling down. If I were to break this down into vectors, both this one and this one are both pulling down, and that pulling down is the same as this one pulling up. The next one is square planar. Square planar is this one, and here we have a highly symmetric shape. It looks like an X, all right, and you can cancel it out. You look at it like that. That's a highly symmetric shape. And the last molecular shape that's highly symmetric is octahedral. All right, so there are my non-polar shapes. Now we're going to switch to polar shapes. Polar shape, well, the first one is trigonal pyramidal. All right, that's a polar shape. You can see it's not symmetric. I've got all my things on the bottom, and they're all pulling down, and that's not symmetrical. All right, everything's pulling down. So this end would tend to be polar or not polar, and this end would tend to be polar or not polar, depending on what's involved in the bonding. Bent is the next one. Bent is the water molecule, highly symmetric. Depending on electronegativity, either end could be the dipole, depending on what's what. Like if this is oxygen and hydrogen, this end's going to be negative. But if it's oxygen and fluorine, this end's going to be negative. All right. Now, the next one is a seesaw, and a seesaw is this one. This is a highly asymmetric shape. Therefore, it's going to be a highly polar shape. All right. You can see all my bonding is happening like below the central atom, and that tends to make a polar shape. This is the T-shaped. All right, this shape is a polar shape. It's not symmetric. I've got nothing counteracting this molecule on the bottom. There should be one on the top. And the last one is square pyramidal, and that's this shape, where I've got a square, this like, and with this, other one on the bottom, and that tends to be the last of the non-polar shapes. Sorry, polar shapes. So I said that wrong. Square pyramidal tends to be a polar shape. All right. So here we have my polar and my non-polar shapes. Here they're all listed. All right. Here they're all listed there. And one thing to remember with these non-polar shapes, all the species need to be the same for you to end with a non-polar molecule. All right. And that is the video. Thank you. Here are my sources. These are, I put them in the forum. I hope this has been helpful, and let me know if there's anything else I can do for help.